So this this root table will be focusing on interoperability and visualization of spatial time data. So we are focusing at CartONG, because I work both for the University of Grenoble and CartONG. We are focusing a lot on space, but often space that have a time dimension. Okay? And we are going to speak about the time dimension today. And there are several time dimensions. And one time dimension is the time dimension of the event. So for example, you have an earthquake at a given time, and you may have a secondary smaller earthquake, etc. So that's the event. But then you have other events that are destroyed buildings, okay? And they can be measured at some time, and then the measurement will be, the data will be analyzed later. And so we have the time of the event, but we have also the time of the analysis, and we have different timestamps on this. And also the data may evolve, and we may have different data organization over time. And so we are going to speak about all of those. And so I give the floor to Jules Kouadio from IFSTTAR. We will be speaking in French. If you don't understand French, please sit there, and I will be doing interpreting. Jules?
Bien, merci à tous. Je suis Jules Kouadio de l'IFSTTAR. L'IFSTTAR, c'est l'Institut français qui s'occupe des transports, de l'aménagement et des réseaux. Alors ma présentation va porter sur tout ce qui est données temporelles qui entrent en compte dans la prévention, la prévision, l'alerte et la gestion des crises. Alors cette présentation-là va s'appuyer essentiellement sur deux axes, l'axe de mes travaux de recherche et l'axe de ma petite expérience en tant que Information Management Professor à OCHA pendant la crise post-électorale en Côte d'Ivoire. Alors au niveau de mon expérience de recherche, il faut dire que mes travaux de recherche au niveau de ma thèse de géographie portaient sur les crues rapides. Les inondations rapides, ce sont les inondations qui surviennent à la suite de précipitations intenses et donc qui, compte tenu de la vitesse des écoulements provoqués, engendrent beaucoup de dégâts, des pertes en vie humaine également. Alors, je vais passer sur la description technique de cet aléa-là, mais il faut relever que ces aléas-là, dans leur gestion aujourd'hui, sont prises en compte à deux niveaux. Il y a un niveau vigilance qui est géré par un service qui s'appelle le CHAPI. Il faut dire que la vigilance obéit à une notion de seuil de palier qui concerne la caractérisation des cours d'eau en termes de niveau. Et de cette caractérisation-là, le CHAPI, qui est un service spécialisé dans la description de cet aléa-là, donne des instructions aux populations en termes de conduite à tenir. À côté donc de la vigilance, il y a la notion de l'alerte qu'il faut intégrer. L'alerte, contrairement à la vigilance, obéit à une logique de tout ou rien, c'est-à-dire qu'il y a alerte ou il n'y a pas alerte. Il n'y a pas de niveau de palier à franchir. Donc une fois que l'alerte est enclenchée, on ne peut plus revenir en arrière. L'alerte est mise en application par les autorités compétentes relatives au ministère de l'Intérieur et mise en œuvre avec le concours de la préfecture en application au niveau des mairies par le maire et avec répercussion donc sur les populations, avec la mobilisation éventuelle également des services tels que les pompiers et la gendarmerie. À côté de cela, il faut dire que dans le fonctionnement actuel, il y a des limites. Les limites sont au niveau du linéaire d'eau surveillé, qui concerne essentiellement les grands cours d'eau, alors que les cours d'eau qui amènent les crues rapides sont très peu surveillés, très peu instrumentés. Il y a la question également de la destruction des stations de mesure qui sont détruites lors de la montée ou de la violence des écoulements produits. Le principal reproche qui est effectué, qui est formulé à l'endroit du dispositif actuel, c'est la chaîne de transmission de l'information, depuis la caractérisation de l'aléa jusqu'à sa transformation en information d'alerte ou de vigilance aux populations. Donc, cette temporalité-là influence beaucoup les prises de décision en termes de préparation également pour les services spécialisés. Donc, le travail de ma thèse, c'était donc de voir dans quelle mesure mobiliser le citoyen dans le dispositif en utilisant son smartphone dans une approche plutôt bottom-up, alors qu'on est dans un dispositif qui est officiellement top-down. Je vais passer les éléments contextuels qui entraînaient justement l'apparition des smartphones en termes d'applications dédiées justement à l'alerte au niveau des populations. Il y a eu des applications d'ordre privé, des applications communales, des applications au niveau national qui ont fait leur apparition. Je passe également l'opportunité contextuelle qui représente justement le nombre important de smartphones en France et les chiffres qui prouvent qu'il s'agit, qu'il y a en tout cas une opportunité évidente à investir le domaine des smartphones pour mobiliser justement les populations dans le dispositif d'alerte en place. Donc, c'est tous ces éléments-là qui m'ont amené à réfléchir à quel serait éventuellement le système d'information idéal à mettre en œuvre pour pouvoir proposer une réponse efficace en termes d'outils qui pourraient amener les citoyens à contribuer. Donc, à ce niveau-là, j'ai été amené à étudier différentes temporalités qui sont entrées en compte dans ce travail-là. Il y a la temporalité qui concerne l'aléa en termes de caractérisation de l'événement hydrologique jusqu'à sa transformation en pic de pluie et également en pic de crue. Donc, entre la tombée de la pluie et la montée de l'eau qui entraîne justement les dommages, il y a une certaine temporalité à prendre en compte dans l'analyse. À cette temporalité-là s'ajoute la temporalité de la dimension, on va dire, philosophique, de la dimension logique qui est derrière. Dans quelle temporalité on se situe par rapport à la gestion du risque? Est-ce qu'on est dans l'alerte? Est-ce qu'on est dans la vigilance? Est-ce qu'on est dans l'anticipation ou est-ce qu'on est dans la prévision? Il faut dire que les crues rapides surviennent donc à la suite de précipitations intenses de l'ordre de 100 à plusieurs centaines de millimètres d'eau en l'espace de moins de 24 heures et donc laisse très peu de temps aux autorités compétentes d'alerter les populations. Donc il y a la logique donc, de la gestion de risque qui s'appuie aussi dans les éléments à prendre en compte dans la mise en œuvre d'un système adapté. Au niveau de cette logique-là, sont mis en œuvre des outils. Alors les outils aussi obéissent à une certaine temporalité. L'avantage de l'outil smartphone, c'est qu'il peut se positionner dans toutes ces temporalités-là. Le smartphone peut être mobilisé au niveau de l'alerte, mais il peut également être mobilisé en amont et en aval de la gestion de crise. Il peut être mobilisé également en ce qui concerne la prévision et également la vigilance. Des outils ont déduit le comportement de l'action des managers, des principaux gestionnaires de la crise ou des risques. Donc il y a la dimension de la temporalité des acteurs. Mais les acteurs sont limités justement par l'action individuelle qui revient justement aux citoyens face à l'urgence de la situation, face au danger. Donc, dans l'ensemble, on a toute cette temporalité-là entre la description de l'aléa jusqu'au comportement des acteurs sur le terrain qui doivent être intégrés dans les dispositifs en place. Je passe aussi plus spécifiquement sur la question même de la temporalité des outils qui sont mobilisés et actualisés pour justement mettre à jour les informations qui vont à l'endroit des décideurs. Je vais maintenant rapidement parler de mon expérience au niveau de OSHA en tant que Information Management Officer. L'idée derrière cette expérience-là, c'est de mettre en avant la question des données qui sont mises à jour et agrégées au niveau des organismes en interne et diffusées et collectées aussi en interagence ou interorganismes sur le terrain. Au niveau de OSHA, il y avait un certain nombre de produits, de rapports qui sont régulièrement produits. Et la temporalité d'actualisation aussi diffère en fonction de la nature de ces données-là. Il faut dire que ce fonctionnement-là est aussi identique pratiquement en interne. Il y a par exemple des cas de situation, et également des données en termes de mouvement de population qui sont agrégées en interne. Il y a des descriptions relatives au pays dans lequel l'organisme est en action. De ce fonctionnement-là, on déduit une compilation entre acteurs, entre ONG ou entre opérateurs sur le terrain humanitaire, qui sont actualisés aussi avec une temporalité plus ou moins différente. Donc la temporalité au niveau de problématiques comme la protection ou des problématiques comme la sécurité ou des problématiques comme le genre n'est pas en tout cas la même en ce qui concerne les différentes organisations. Et donc OCHA au milieu essayait de coordonner toutes ces informations-là et de capitaliser ces données-là. L'idée aussi derrière ce travail du terrain, c'est que chaque organisme cherchait à savoir qui fait quoi où. Donc, quelle est l'action de l'organisme en charge, par exemple, de la santé, ou quel est l'organisme en charge du terrain sur l'opération. Donc, la question temporelle est aussi mise en avant dans la compilation des données. Et donc, il faut dire que le gestionnaire de l'information sur le terrain, parfois, doit manipuler plusieurs formats de fichiers différents en fonction des organisations. Là, par exemple, on a celui que les gestionnaires des populations, en termes de mouvement de population, géraient, qui devait être compilé avec celui du HCR, qui devait être compilé avec celui de l'organisme international, l'Organisation internationale des mouvements de population. Donc, tous ces éléments-là devaient être compilés dans un seul fichier. Donc, ça demandait une charge de travail pour le gestionnaire de l'information, qui derrière doit produire sa carte, doit produire également des points de situation et des graphiques. Donc il y a toutes ces informations qui tiennent compte justement de l'importance de ce qui est la composante spatiale pour pouvoir avoir des informations précises. Donc, on me signale que mon temps est fini. Je vais aller rapidement sur les éléments de conclusion. Il faut dire juste que l'importance de travailler avec la notion de la temporalité est capitale au niveau du terrain, en tenant compte de la temporalité des outils, en tenant compte de la temporalité avec laquelle les acteurs arrivent sur le terrain. La qualité de l'information varie plus ou moins et surtout demande un gros travail de compilation. Et donc, il est important au niveau du terrain de mobiliser les réflexions autour de l'interopérabilité des données. Je vous remercie.
Thank you very much, Jules. Now I will be giving the floor to Mayeul. Marlène from the University of Grenoble will be speaking about one of the challenges that we all have when we use space data is that we use territories, so countries, regions, municipalities, and for those who have like shapefile or spatial light files, but they change over time. How do we manage this? And how do we manage the attributes, the data that are related to this? And I think this is relevant to the field, but also to desk. Si on passe en plein écran, ça nous amène d'autres comme ça. Si on lance, s'il vous plaît,
Okay, so thank you very much for being here today, and thank you for having invited me. So today I will present you a work which is the one of Camille Bernard. She's a PhD student in our team, and our team is the STIMO group, which is a research group in geomatics in the LIG lab, which is one of the main computer science laboratory in the University Grenoble-Alpes. And I will talk about how is it possible to manage changes in territorial partitions over time, considering that we have proposed ontologies which are called TSN and TSN change and an algorithm to detect the changes. So the topic of this talk is territorial statistical nomenclature, which are division of territories into units at several nested levels, and the main objective of such division is to support statistical data mainly. So you have here two examples of such TSN. One is the nuts at the European level, and the other one is one of the Australian bureau. The problem we are dealing with is that modifiable area unit problem that has been addressed by Openshaw and Taylor is the following. Considering that you have individuals that here are depicted in blue and red and which represent whatever you want, the zoning effect at time t is that if you consider one division of the territory, you can get the results where the majority is to the blue, whereas if you consider exactly another division of the territory, the majority is to red. And this effect is the same consider the time that evolves. For instance, if you have these two divisions of territory that go through T1 to T2, you have another representation of data on the territory. So, territorial divisions change over time, while statistics need for stable divisions. You have here the example of France in 2016. And usually the answer is the following. Divisions are freezed for a period of time. This is a discrete approach. And then changes are restituted in a new version of the TSN. That is to say that the drawback of such an approach is that it, of course, solves the problem during the period of stability, 3 years, for example, in the nuts. But over a longer period, it's really hard to determine if the causes of variation are due to data or division, because both can evolve at the same time. So, if you want to get data on the new territory division, you can use spatial interpolation methods, for instance, that help to break free to break free of territorial divisions. But it's a widely used method for estimating data has the main drawback that is often provide you with data on the latest version of the territory only. So it's like if you erase the changes that have occurred through time. Our assumptions is that territorial structure in itself is a valuable information and that the evolution of this division is also valuable information. And if you want to provide statistics on different territorial divisions, it's useful to be able to manage the evolution of the territory. Societal, political, economic context allows to better understand the territory and its evolution over time. So our approach is to consider that the modifiable area unit is now a potential, and this is not our idea but the one of Roland and Madeleine. And what we provide is the capability to describe changes between two versions of a territory using different attributes to describe this change, and this helps to understand the dynamics and to better use data on different territories, versions of the territory. So the challenges we address with our approach is to support stakeholders in understanding territorial changes to better exploit this information. We are able to publish data in different TSN versions to identify, describe, and contextualize changes. And this is a first step toward decision support that helps to simulate the evolution of a territory over time, to compare territories by their trajectory of evolution over time, and to help to take better decisions at the end. So, there are a lot of existing ontologies that help to describe the territorial division, and you have here some different examples, but for review, I address you to the PhD of Camille Bernard, but the main problems is their lack of genericity and very few support to manage really the evolution. So, our approach relies on the semantic web and linked data to meet our objectives. Basically, the idea behind semantic web and linked data is to link information of course, over time in what concerns our approach, to describe everything with different vocabulary that helps to tag information, to define sets in order to be able to compare and make things more interoperable, and to contextualize, that is, to connect data from my system with the semantic web at large, and to connect information with other domains. So this is just an example. And then you can reason on the data using all this technology. So our approaches, TSN and TSN change, are two ontologies that help to model changes in territorial positions over time and to reason on it. Just to give you an overview of what is TSN ontology, well, it's something very simple, in fact, that helps you to describe your nomenclature. This is here the nuts from Eurostats. A nomenclature has different versions. If you here on the left, on the right, you can see the different version of the nuts through time. And this nomenclature is and help to describe the territory, which is also available in different versions. Then the structure itself of the nomenclature is built upon different levels of information and at the end on different units of information. So you can see here that nuts has 4 levels, and at the biggest level you have the country. So you can go, of course, thinner in the description. But this is not enough, because with TSN ontology you can describe the different versions of a nomenclature. Here you have 2 versions, 1999 and 2003. So just here a very small example that shows that at 2003 version you have one more unit, which is called ES64. But this is not only what we need to have. We need to have a description of change between these 2 versions of the nomenclature, and this is what is done through the TSN ontology. Just to give you an example, here you have 2 enclaves of the Spanish territory, which are in Morocco. You have Ceuta and Melilla, and during their life, Ceuta and Melilla were part of the same level, in level 2 in the version nuts 1999, but in 2003 they become 2 different territories. So we have now ES63 and EX64, 2 different versions. So we have to represent this evolution to show that this is not anymore the same territory that is referred through the code ES63, for instance. So basically, TSN ontology is the description of changes. We call that bridges of change, and we describe all the different events that affected the territory through time. So this is very small example. I have more complete and complex one, of course. But just to give you an idea of how interoperability is addressed here, we use a vocabulary of the W3C and OGC to describe the validity period through time ontology, and geospatial ontology for geometry's description, for instance. So this is the different example of data we can use to contextualize information, and here we can refer to the official declaration of the migrations of these 2 enclaves. And this is an example of the different typology of changes that we are able to manage through our approaches. So we are able to manage different restructuration in terms of geometry. At the end, this helps us to extract from knowledge. So I go very roughly in this slide, just to show you that we are able to find all changes between 2 versions of a TSN, to describe more precisely the change, and to find the lifeline of one unit. For instance, this is a lifeline, so this is a graphical representation, but the idea is to show how one unit has evolved through time. I don't go into details in the change detection algorithm, but basically it helps to define the filiation links between 2 units. And one main challenge here is to define how far has to move in terms of description and unit to still be considered as the same one as previously? Is it a new unit? So we have a lot of work on how to define what is the identity of a unit. So the algorithm go in 3 main steps to define all the changes between 2 versions of the territory. As a conclusion, just to say that we have now at our disposal a generic vocabulary to describe any territorial structure in a linked open data cloud. It helps us to describe all the versions of these structures and a detailed description of changes. And we also provide a change detection algorithm to identify the different changes. We have validated and implemented our approach in 2 examples, the NUTS one and the Australian one. Well, we provide some different visualization of this information. And for work in progress, maybe I can switch during the discussion.
Okay, thank you very much. So now I'm going to give the floor to Paule-Annick Davoine. So we have seen that we can collect data in the field, analyze that in the desk office, and Marlene just shows us how to manage the structure, the change in the structure of data. And once we have done this, to analyze it more properly, we need to visualize the data. And I give the floor to Paule-Annick Davoine.
Thank you very much. I think it's difficult to talk about spatio-temporal data without talking about visualization and cartography. But the problem to visualize the time dimension into the map is not a new problem, it's a very old problem. And we have some emblematic representation that we can observe in the literature. For example, we have the Minard maps, maybe many people know this map, where the time is represented into the map. And for example, this represents the trajectory of the army during the war, the Russian war. Non? Il n'y a pas de... Okay. Sorry. Okay. And the trajectory represents the campaign of the Russia, and the size of the trajectory represents the change of the population during the war. Okay, and the time is in this axis. Okay, and here we have the context into this represents the context elements to explain the different reasons why there are many people update and etc. And another representation is maritime timetable, where we are the time is represented on the axis here and axis here, and the space is represented by a vertical axis. If we have the departure of the train, okay, and the town where the train go, okay, and you have the time at the for the depart of the train, and you have the time for the arrival of the train. And the slope of the line is the speed of the train. And this map represents the rail network of the rail network and the problems that we can have during the time and the space. Another example is here, is very old example. It is a map collection to represent the different observation, the meteorological observation during different time, different period, and they explain also different contexts of the characteristic meteorological characteristic. And another old representation concern the movement of the population per department in during 80 years. And this representation, sorry, my English is very
It's good. Your English is good.
And we can observe the phenomena during global view, but also through local view. And each circle represents, for example, the evolution of population for one department during the time. But another approach in cartography, we have the cartography proposed semiological approach to represent, to integrate time into the map. For example, we can using a round to represent the movement, for example, like we have see with Minar maps, and we can also represent different various shapes to represent footprint along the time, and we can use small multi-map to represent different different events during the time. Each map represents, for example, here one flow event at each date. Right? But when we have this kind of representation, when we have many small maps, it's difficult to identify a spatio-temporal pattern. And another proposal is to considering color to represent different events according to the time. For example, here we have some track during the volcanic eruption, okay, and each color represents a crack during for a time period. And when we want to represent spatio-temporal data, we have different programs, and the most problem is due to the overlaps and density of data. During the time, each event, many events might occur at the same place at different periods, and some events appear, disappear, and it's difficult to represent the footprint of the map. And when we overlap these different footprints, we cannot see the whole footprint. Another problem concerns the quality of data, because when we have whole data, the quality is not very good. And for example, here we have the footprint of the lava flow, and this is the recent lava flow, but the shape of the lava flow is we have many details of the shape of the lava flow, sorry, but here we have not detail and is less accuracy, and less accuracy than we go back in the time, of course. And another problem is the representation of the data according different point of view. For example, here we have a shape, a footprint of data of the whole eruption, of the whole lava flow, according different author, different observator. And the problem is it is very important to represent these different point of view, because to explain and to compare different process. Now we have different technique. Sorry, we have different technique to try to take into account spikes and time and to integrate simultaneous integrate spikes and time in the same tools. For example, we use interactivity interface or geovisualization interface, where this interface is divided into different views. one view from, for example, to represent a space dimension, another one to represent time dimension, and another one to represent attribute or semantic dimension. And one of the characteristics is that each frame or each view can be interacting between them. For example, if we have a map who represents the location of the avalanches, and here we have the distribution of avalanches during the one period is 20 centuries, and we can observe the
20th
century, and we can observe the distribution of the number of avalanches during this century. And we can select 1 year and have the different location of the avalanche. But in this in this interface, geovisualization interface, is very interesting to integrate different graphs to represent different temporal dimensions. Some time can be taken into account according cycling time. Another time, another circumstances, we can consider the linear time, and we can represent in this graph time width of timeline. And another interesting interest to use, another advantage is to use this kind of interfaces is we can explore data in the global context, in the, for example, overview, and according to your need, we can explore some detail according to your interest or according to your objective. Oh là, d'accord. Okay. In the context of PhD of Jacques Gauthier, we have developed a new geovisualization interface when we can explore in the same time and space, but we can integrate taking into account cyclic time and linear time. And this interface is divided in different views: the map view, the time view, but here is a linear time view, and and here is a we can take into account cyclic time.
It's a polar view, right?
It's a polar view. Yes, okay. It's a pie chart view. The first temporal diagram, for example, represents events which appearing during the interval that we choose, the user choose. On the x-axis represents time through a linear scale. Vertical axis represents time through a cyclic scale. And during the cyclic scale can be modified with the control panel according to different parameters. Okay? Temporal close event can be upgraded in the diagram. Sorry. And okay, sorry. Okay. And we can. The second diagram represents the number of events according to the sixth temporal scale, and the user can choose different sections like we want. For example, when we choose different cyclic time. Okay, I'm going to conclude. With this application, we can identify event propagation along the time, for example, and we can use, visualize the old event and the new event and the spatial repartition of this event. We can also identify events cluster according to the cyclic scale of the 1 year. For example, we can here this event appearing during the same month, and here this event appearing in the same place at the same moment of the years. Another example, we can identify this event occurring during the 3 months, and here we can see on the map the events which appears in the same length at the same moment of the year. Another example to use this application, you can identify a localized cyclic appearance of events. For example, with this event from the graphical alignment of the temporal diagram, this event appears each 150 days during of the 6 scales that we have chosen. Okay. Sorry, we have applied this. We have used this interactive interface for exploring spatiotemporal data for different case studies. For example, to explore flood event in France, to explore homicide event in the United States, and here to explore civil war battle in the USA too. Okay, it is a very big challenge to combine space and time in the map, and now there are various spatial temporal visualization tools on the web, for example, but many of them are time-oriented, and others of them are space-oriented, and the very challenge is to combine in the same time and in the synchronous way temporal and spatial dimension according different temporality and different scale or different granularity. Thank you very much, and sorry more for
Thank you very much, Paule-Annick. That was, I think, very interesting to have both the history and the theory of visualization, and how we apply this with modern tools today. The first map that you've seen, some of them were on their own. Right? And that's very nice to see, and I'm very eager to try those tools that I were not aware of. And now I'm giving the floor to Maria Teresa from the IDMC. IDMC is the Internal Displacement Monitoring Center. It is part of the Norwegian Refugee Council. It's based in Geneva. And she will see how this data that we have collected, and she will speak about the context of internal displacement, how we do interoperability with this. Please.
Thank you.
Sorry? Yep.
It's easier for me. Hi, thank you for the introduction, and the perspective that I'm going to present is quite different. Is how do we see interoperability and working with different data sets from the humanitarian sector? So to start with this presentation, it's important for me to introduce the organization, so you can have an overview of why this is important for us. We are the Internal Displacement Monitoring Center in Geneva. We respond to a mandate from the General UN resolution that is there. Our mandate is to be a reliable source of data and information on internal displacement worldwide. So what we do, our mandate, is to compile information on internally displaced people due to different drivers of displacement. We provide every year a global report with statistics on internally displaced people. Our main, sorry because you cannot see the map. I didn't thought on the brightness of the screen. This is a map showing the total number of new displaced people by conflict and disasters in 2017. And as you can see, there are different incidents of displacement that happen almost all over the world. The blue dots display the number of people that have been forced to move due to disasters, and the orange dots display how many people were forced to move due to conflict. Now, all the information that we compile comes from different sources. This information comes from national authorities, civil society, media, United Nations, the Red Cross and Red Crescent movement, private sector, and other sources as well. So as you can imagine, compiling and putting together data from different data providers, different sources, is really challenging. Basically, what we do is to monitor different cases of displacement due to conflict, disaster, and development-induced development projects, like development projects that force some people to move, like relocation, resettlements, and things like that. We compile different types of information that can come in the form of PDFs or raw data. We can also estimate the number of people displaced by using satellite imagery analysis, and as I mentioned before, also media. And all this data or information comes using different indicators or different terminologies. And we compile all this information and data into a global internal displacement database. It's a global repository. And basically, the metrics that we produce are new displacements. The example is the first line over there. Is the number of people displaced, for instance, over 1 year. How many people were displaced over the year? And we also try to collect information about the number of people that have returned. When we talk about IDPs, we are talking about people that is forced to move. And returns is when the people that was displaced can go back to the original places of residence, or when they have an alternative and durable solution. The total number of IDPs, we call it a stock, because it's the total number of people displaced at a certain point in time. For instance, as of today, how many people are displaced in one place as of today? While the flow is like the first metric, the new displacement is like a flow. How many people was displaced during a period of time? So the data model that we have, the information that we collect is illustrated in this graphic. So we try to collect information about people resettled, returnees, local integration, and people that have crossed a border as well, and they potentially become refugees. So there are different challenges to compile information. We have the geographic or the coverage challenge. Sometimes information that we receive is partial. They don't cover all the areas affected by a certain event. The information can have different forms of aggregation. Can be published as a location, as a point, as a campsite, but also as an area, like the number of people displaced in a province or something like that. The temporal coverage is not the same. It changes all the time. When there is an humanitarian operation, there are different agencies collecting different data at different time, and sometimes the difference in the final figures that they produce do not reflect necessarily changes in population, but changes in the methodology. Disaggregation of the data can represent different sectors of the population affected. And something that is almost is missing sometimes is the metadata. It's really difficult for us to compile data along with the methodology that was used to collect this information. Then we also try to collect, as I mentioned before, some additional metrics like returnees, cross-border movements. Thank you. So now, talking a little bit about interoperability. As I mentioned already, there are different terms used to report on internally displaced people. Some organizations can report on displacement, others in evacuations. So the vocabulary used is really wide. But we also have a diverse the information that comes to us, or the information that we find, is really diverse in terms of formats. We can receive information published as PDFs, or as a JSON, or an Excel, or even as an image. And regarding the time dimension, sometimes some organizations report after a disaster, in the first phase of a disaster. Now I'm going to focus on disasters, then I'm going to go back to conflict to have a vision of these two types of displacement. Here in this graphic you can see three different phases of the disaster management system. For instance, there is the preparedness, the emergency, and the recovery phase. And the data during these phases of the disaster management cycle don't come on a standard or on a way that is easy to to understand. Sometimes there is a lack of a baseline, like pre-disaster information. And then what happens after a disaster, is that the information collected gets less frequent over the time. For instance, in this graphic, what we try to represent are the 50 biggest disasters from 2008 to 2015, and the larger events from 2016. And what this graphic is showing is that most of the reports, like with figures and information about people displaced, are published just on the first days or first months after a disaster. But after 1 year, the information is really scarce. It's really difficult to find information about what happened with the people. This graphic shows more or less the same, but for conflict. This graphic shows how old our data is in the database. For instance, here we have this orange line that is showing how many people we have reported as being displaced, but during the 90s. And since the 90s, we haven't received an update of what happened with these people. So the level of information and updated information can vary a lot according to the crisis. So when I received an invitation for this panel, there were a bunch of questions, and something that captured my attention were the tools, but also the processes that are needed in order to improve the interoperability of geospatial systems in respect of the time dimension. I'm just reading that. And regarding the tools, I think that we can represent the data if we have the data. So for us, the first obstacle that we face is to compile information, because the different terminologies, different formats, and different methodologies also that were used to collect the data. So we need to be sure that we are using and compiling aggregated data that is comparable. And this is really challenging. So among these challenges, like we face on a daily basis, is usually the information that is produced in the field is not meant to be used by other people. Like if we collect information as one organization, we just focus on our goals. But we don't see this information as a service for other organizations. Then the lack of metadata and methodology. Like when sometimes organizations publish information, they don't publish the methodology, as I mentioned before, nor the metadata. And the data sometimes is not comparable, because can cover different areas, can be collected using different methodologies. Therefore, if we put together different information collected with different terminologies, methodologies, and so on and so forth, maybe the result that we are going to have at the end is going to be wrong. So these are a lot of variables that we need to take into account. Then another challenge that we face is that the information that is collected usually responds just to the emergency phase in the case of disasters. And after some months, the information is not published anymore because there is a lack of attention. Maybe there is going to be another disaster that is going to be more mediatized, and, or humanitarian organizations are not present on the field anymore. So what is needed in order to have a better overview of in my case, what I focus on, internally displaced people, is to have better baseline information. And I think that almost all the people and organizations working on the field face the same challenge, the lack of baseline information. We need better collaboration, common terminology and metrics, if it is possible. It's really challenging, but it would be nice to have. Data, when we publish a map or data, we need to think in this information and data as a service for other people, because it can be used for other people and for other purposes. So that's it. Thank you very much.
Thank you. Thank Thank you very much. That was very interesting. I would like to add some things that my tesa is very modest, but the IDMC is doing excellent work in that they received the mandate from the UN. So I don't know if you control receive that mandate. And every year, the UNHCR is waiting for the IDMC to publish numbers of IDPs so that it can be incorporated into the UNHCR annual reports. So it's this work that you've done, that you've seen, it becomes in the end the official international word numbers for IDPs, and that's made a large part of it in rush mode. So you see that evolving the methodology and seeing the various versions of the data is very important, which gives me to lead to the presentation of Vincent Morin, who is a developer at Oslandia, a company based in Rhône-Alpes, developing free and open source software. And he will demonstrate how we can manage those versions of data with different tools. And he's not only a developer, he's an artist. So he makes quite an original way of making presentations. And so I have a webcam here. Oh, wonderful. So he draws as he speaks, and that's very impressive. I very love it. So I think it should work this way. Okay, I need to do share the screen. Not that one is the one. Now you see me. I want this. We'll make it. Oh yes. Okay. So.
Sorry for that.
Oui, c'est bon. Parfait. So, c'est pas vrai. Ok, alors je vais la tenir peut-être comme ça, parce que là, sinon, je sais pas si elle est comme ça. The professional, huh? This is my webcam, but he has the way to make it work. We'll make it.
Yeah,
Okay,
that will be the manual. So I'm going to talk to you about QGIS versioning, which is, I think, like, who knows QGIS? QGIS? Good. So it's an open source geographic information system. So a tool to make maps from different types of data. So my job is mostly plumbing. So day after day, I receive different format of data, and I try to make it fit into the information system. So there are some of them are exotic, and I'm really concerned about interoperability because it's a lot of wasted time just to convert the data. And what I'm talking about now is a way to represent, the way we've chosen to represent temporal data, historized data in the database. So it's going to be into the detail, very pragmatic, not theoretical, and maybe we'll learn many things. But this is the way it works, and it originally was a project for the province of Valencia in Romania, who was developing their drinking water network. And what they wanted is to track that over time. So they had us develop this tool. It has been then used, so this is Romania. And also drawing helped me slow down because otherwise I think I talk too much. So bear with me just a second. So this is the water network of Romania, and that evolves over time. So this was the original customer for this project, like the where it comes from. Nowadays it's used daily in Nigeria, and it is used to track population motions. So people, because of war and other disasters, they move from camp to camps, and there is a need to have an history of the data because you collect data over time, but the data has a certain period of validity, and then you go back and have you update the data, and you need to track what happens in time. So this is the area of application of the tool as of today. I've heard that it's also used in Belgium for collecting environmental data. So everybody is interested in tracking data over time. The way it works, the model of the information system is really simple. So it's a centralized database. So the data is centralized, which is a must for good data, in my opinion. And you have people that are connecting and updating the data with various medium, say tablet or laptop. And one of the design constraints at the origin of the project was that some people are collecting data in the field and they don't have internet. So poor guys, this was for water management. So and so the tool is made such that you can take part of the data, make your updates in the field, and then go back and update the database. So this is completely. And I'm gonna talk a bit more about the implementation details. So you have a database, and for those who don't know, many of you, a database is simply a name for a big bunch of tables. Like you have data, and geographic data are exactly the same, except that there is one data here that is a geometry, and this is how you store geographic data in a database. To this table, we're gonna, so this is your geometry, this is some of your attributes here, so this is your data. So this column we're going to use, you usually have it, it's your unique identifier. And what we're going to do is we're going to add, to historize those data, we're going to add 4 columns that are the begin, the end. So when the data starts to exist, when it ends to exist, and a relation parent and child. So if you take a specific row here, and somebody says that this geometry or other attribute is not valid anymore, needs to be updated completely. What happens is that you don't erase anything, you create a new record that is the, so you add a line to your table and you say, so this one was valid in the first version, but in the second version it stops to exist. This one starts to exist in the second version. And you still relate this one to its origin. And with that simple implementation, you are able to track the modification of things over time. So if you have a new thing, so it's not something that evolves in time, but something that appears, you just add a new record with a start time. And with that, you are able to view the data that is at any time, like say the current version of the data is all the data that doesn't have an end. All the other data you can just filter out and see what is the current state of your data. And you can do that like with a constraint about the end at any point in time. Since it's used by people who are not database experts, there is a graphical user interface that is QGIS. So that must be simple enough for people who are not GIS information system experts to do the job and update the data and see the data in the time. So this is why there is a graphical interface, and it's really important for the dissemination of the tool. So it's relatively easy to use, and you can see that maybe this afternoon if you come to the workshop. So I'm done. I just want to represent. So this is one way of doing things. And if we want to discuss interoperability, I think we need to go down to this level of details of implementation, because the simple name of the column it's what, in my opinion, interoperability is all about. Just the names of things and the way you do things matters, because devils is in the details. So there are as I see it right now, there are two kind of time events, time-related events. So there are punctual events, something that happens like at an instance, so a disaster, like an earthquake. So we have temporal and events that are like the validity of data, as an example, is in another category, that is events that have a validity on a certain time interval. And when you're representing things, one of the issues here is the going from one state to another state. How do you interpolate in time? So those are questions that I'm curious to talk about. Thank you.
Thank you. Thank you very much. Just showing now the full picture. As I can see that you can use the term, the full picture. It was really enlightening. So I'm going to give the floor to some questions. But just before this, I have a question. How many people already have registered for the QGIS versioning workshop this afternoon? Okay, among you, okay, maybe other people do have. So you might have noticed that here sometimes the internet and the Wi-Fi is not working very well. And we discovered that yesterday. So we prepared the workshop initially so that we use the database installed at the University of Grenoble, but it requires the internet. We have USB keys with all the setups, all the database, and even QGIS if you don't have QGIS, to install it if you wish on your laptop during the lunch break. So I will be sitting along with other colleagues near the the dining room tables upstairs. So in the first part where there are the stands, you see on the right there is the place, the exposition area for CYBIS University Grenoble Alpes, where I suggest you come during the lunch break with your meal if you wish, and we help you make sure that you don't need the internet for the workshop. So now to the questions. Who wants to start with the question to this very nice panel? Yeah, please.
Technical question about the relation you drew with your database. The begin, the end, is it just a numbering of the versions, or is it like a timestamp?
In this particular case, yes, it's a numbering of the version. It's not a date.
Okay.
So, and I'm questioning that. I'd rather now have just a date, a plain timestamp, because it's I think more portable in terms of concepts.
Yes.
You just need a simple join to like have there is a metadata table that makes the correspondence, but I'm not exactly sure there is the need for that.
It's also kind of a redundancy in terms of data, I think.
What do you mean?
Because end will always be the start plus one.
No. No, because you can have one particular line of data that stays like forever, and there is plenty of modification in between.
So the counting of the version is globally, not for one feature.
Yes, the
okay.
version
Okay.
is you make a modification, you change plenty of lines, and then all those lines they have this revision number.
Okay.
It's the day you change the data.
Okay, so this will be explained in detail in the workshop.
Okay.
Will come. Other questions? Maybe yes. Yeah, please.
The question about application CDIRA that you talked about, so is it something that your team has developed, and is it kind of openly available, or like, yeah, what's, if you can...
CDIRA is a whole application, and which has been developing into STEAMer team in Laboratoire d'Informatique de Grenoble. And
It's a quite old application.
Yeah. Okay. Yeah, it is. And the graphists have been developing in the same laboratory.
But it's not publicly available.
Not yet.
Graphists, yes.
Okay.
You can try, but it's not disseminated.
The PhD has been defended at the beginning of October, so I guess that in a few weeks we will have online the possibility to use, maybe to also to get the code of the application.
Okay, maybe one or two more questions. Yes, please. Sorry.
Could you give us an example of like you showed the time wheel and the linear time, and when should one use one or the other?
When we use time wheel,
yeah.
for example, when we want to explore data about I don't know, les déplacements quotidiens.
Daily movement of
The
people?
daily movement, sorry. Okay, and and we want to know at what time, for example, there are many people at this place, or what is the trajectory of different people and during the time. and we can use time width because time width usually we think the time width represents the cyclic time, but it's not. Cela peut être discuté.
In fact, each time you think that you have something that is cyclic in your data, and the approach with graphics is that even if you don't know, if you have some cycle in your data, you can use the tools to make this emerge from the data in space and in time. But cyclic is something that you can have in data that could be in everyday mobility, but also for a longer time.
Yes, in this application, the first idea is to identify some cyclic pattern, and the reason why we have tried in the first time the time wheels, but after we think that it is possible to identify cyclic pattern when we use linear time.
So if I may to give another example, so first, if you have daily movement of people, you see that they go to their job place and they turn back. We'll show you an example during the workshop. So you see at 7 or 8 in the morning and at 6 or 7 in the evening, there's a peak of movement. But if you look at internal displaced people or population movement, you could see that in the summer, people go in the mountains or in the warmer areas, whereas in winter they go back in the valley, for example. You have some populations doing this. So you can see that the same tool could be, same device could be used for daily data or annual data. You have the question?
Sorry. And actually we have many data, and we don't know what data can inform us. And this kind of interface, geovisualization interface, offers the possibility to explore data and to identify some cycle, for example.
Just an additional information, if you want, you can go on the website of the STEAMER group, and you have now, I think it's
just
fresh
this morning.
Very fresh information, because so you can have some videos that show the way you can use graphics for exploring your data. So STEAMER is STEAMER.int.
As a question here,
je l'ai pas mis. S'il y a un web, steamer.imag.
C'est comme ça, c'est ça?
Ouais, .imag. And you have a menu which is called software, and in this menu you will have graphics.
Okay. Maybe one last question.
Well, my question is for Maria Teresa, because you mentioned like the challenges of like all the different data format, data time frame for like collecting all the data about the IDPs. And I was wondering about the satellite images to detect like the IDPs or to get to these estimates. Like, so how reliable are the images and how complicated it is? Because also there like it goes to methodologies, data availability. So how reliable are these satellite images and how feasible is to estimate IDPs?
Okay, that's a good question. Actually, with satellite imagery, what we can see are the roofs of the houses. And the quality of the images, it depends a lot on the region and different variables. But we use satellite imagery when we don't have other sources of data. So depending on the context and what it is available, we fill gaps in information. And one of the ways to do that is to use satellite imagery. Now, estimating the number of people displaced by housing destruction is a straightforward process. Basically, what you need to have is population or exposure data, like density of population, or the average household size. The problem is that with the satellite image, if it is just an optical image, you have just the roof. And what you can think that is just one floor house can be a building really high. So the element that is missing to estimate how many people could be living there is the altitude of the building. And if you want to scale up the analysis, that takes a lot of time. However, the process of using satellite imagery has been used for a long time. It's quite reliable, and sometimes it's the only source of information that you have, most of all in remote areas. It's easy to deploy. It's not that expensive anymore. There's a lot of open data from Sentinel, for instance, and so it's easier to do. The analysis is not complex at all. The limitation is the average household size. I don't know if I replied your question.
No, but I was wondering, like, in the global map, like that you show us, like all these estimates of the figures.
Oh.
If you need to give, like, what percentage is being calculated from satellite images out of all these over the
Oh,
map?
really small, like
Really small,
0.0001%. So we just apply it in a few cases. Yep.
Okay, unless there is one urgent present question, I think, is there? No, I think we can call it to an end. Thank you very much to all the panelists.